so I'm going to open up again and go into the November 2017 Extended Maths mock. I've only got about 14 minutes to try and do this 35-minute question, but sure, we'll give it a go, see what happens. We're just waiting for it to load. Unfortunately, I can't open it and then start the recording. I have to start the recording first, so apologies for the wait. Let's see. Right, so down to question 8. We've got a question about traditional greetings. We're given all of our notation representing males, females, handshakes, kisses, bows, smiles, etc. Table 1, which we can fill in. Table parts A, B, and C refer to table 2. So this is what we're looking at for the first few parts. So write down in words 2 patterns from table 2 for the number of handshakes. So I'm only looking specifically at the number of handshakes, okay? So one suitable pattern could be the number of handshakes goes up 1 more than the previous one. Okay, so the first one goes up by 1, the second goes up by 2, third one goes up by 3, and so on. We could accept that it is a quadratic progression. Okay, we could accept, quadratic. We could accept that the second difference is a constant. Okay, the second difference is a constant, which is, well, the first difference is 1, and then that's 2, that's 3, 4, so the second difference is 1, okay? You need to have 2 things. You cannot say as the number of males goes up, the number of handshakes goes up, okay? Determine a general rule for the number of handshakes in terms of the number of male colleagues. Right, so we have our sequence, 0, 1, 3, 6, 10, okay? Our first difference is 1. Whoops, apologies. That's 2, that's 3, that's 4. So that's our first difference. Second difference. Okay, I'll pull this back a little bit. Okay, second difference, so is going to be 1. 1. 1. That's my second difference. So this is a quadratic, okay? First difference, second difference is 1, so the number in front of the n squared is going to be, 0.5 n. And I'm not actually looking at n. In this case, I'm looking at m squared. Okay, so if I now need to kind of figure out what the other part of this sequence is going to be, if I look at the table that this is going to produce when m is 1, 2, 3, and 4, when m is 1, I'm going to get a value of 0.5 out. When m is 2, I'm going to get 2 2s are 4. 4 times a half is 2. When m is 3, I get 3 3s are 9. 9 times a half is 4.5. When m is 5, 5 5s are 25 times a half is 12.5. Alright. So if I look at then, remember how we go about working out these quadratic sequences, the difference between what we've got and our original sequence. Okay, so our original, I'm going to subtract off this part. So I notice that if I take those away, I get negative 0.5. 1 take away 2 is negative 1. 3 take away 4.5 is negative 1.5. 10 take away 12.5 is negative 2.5. And this is a linear sequence. Okay, and it is going down, common difference of negative 0.5. Alright, so it's going to be negative 0, so I can use the formula, or I can just try and figure out, I know it's going to be negative 0.5n, I should keep the same notation, n. So when m is 1, I get negative 0.5. When m is 2, 2 times this gives me negative 1. When m is 3, okay, so that is our sequence for the linear part. So the rule is, so we've got number of handshakes is equal to 0.5m squared. Not sure if you can see that. Let me move it up. Subtract 0.5m. Okay, and that is our sequence. Now you can do that by pen and paper and then just write the formula down. Okay, that is worth 2 marks. There's a lot going on there. Okay, there's so much going on. It's making me wonder if I'm in this. So, all right. So, in case of having to work out the formula, very doable though, and it's what we've been practicing this week and last week. Right, verify your general rule. All we need to do is to substitute a value in. So if I substitute in m is equal to 5, then h is equal to 0.5 multiplied by 5 squared, subtract 0.5 times 5, so I get h equals 12.5, take away 1.5, which is equal to 10. So the rule is verified. So we need to actually maybe state that. So h is 10 as it is also in the table. Hence rule is verified. Alright, D. Okay, so this is the biggie, the last one. Investigate the general rules for the gradings when there are equal numbers of male and female colleagues. You can add more tables, more values in table 3 to support your investigation. In your answer, you should do all these things. So what I'm going to do is, I'm going to do a Kate. I'm going to copy and paste that, and then I'm going to try and do as much of this as possible. So predict more values and record these in tables. So, excuse me, investigate the general rules for the gradings when there are equal number of males and female colleagues. Okay. Alright, I'm just going to stop it there and I'll come back in a second. How can I pause? Let's see. I'll be back in a second, and the bell's about to go, and I've got to go to co-curricular. Alright, sorry there, I'm back. Let me just reopen this up. Alright, so we are done on question 8. Last part of the question. Alright. So we are looking at this table below. We want to see if we can predict more values and record these in the table. We're looking at the number of males and the number of females being the same. So if we just go straight in and put in 6 numbers of males and females, we make a prediction using this. Okay, well, this is the number of handshakes. We've already worked out that it is a quadratic sequence. It is going up, having a second difference of 1 each time. I can actually do the next one. So that's gone up by 5 that time, so this one's going up by 6, so it's going to be 21. Alright. The number of kisses, let's see, so that's going up by 2, by 4, then by 6, then by 8, so then by 10, then by 12. Alright, this is looking like again, a quadratic, but more specifically, it looks like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. And this is looking exactly the same. And this one, 2, 11, 27, 50, 80. Sorry guys, somebody is on my phone. 1 second. Alright. Oops. NBC 3, 2, 1. Unlock, resume. Okay, so this last one, writing it out, the first difference goes up by 9, 16, 23, 50. And then the second difference is 7, 7, 7, 7. So if I kind of just scribble that, that's going to go up by 7, so that's 37. So that's going to be 107. So it's just a quadratic, exactly the same. It's just bigger numbers. So add on 7 to 37, I get 44. And that's going to be 151. Alright, so I'm doing this quickly. Alright, so I have predicted more values and I've recorded these in the table, okay? So the mark scheme actually says correctly predict 1 term for any 2 sets of data. Okay, I've done that. You get 2 marks, correctly predict 1 row for the 5 sets of data. So these are the 5 sets of data, okay? I've done that. I've done 1 row. Correctly predict 2 rows, okay, and that gets me 3 marks. So I've done 2 rows, that gets me 3 marks. 2 rows, and that gets me 3 marks, okay. Write down in words patterns for K and B. Okay, well K, we can see, so it's just write down in words. So let's have a think. So we want to attempt to describe a pattern here. So either they're all increasing, or recognize the pattern for S and B are the same. I can recognize, yeah, that H is equal to K over 2. Okay. So this is also a quadratic sequence. I can also notice that this is B. So number of bows, B, is equal to number of males squared. because 1 squared is 1, 2 squared is 2, 3 squared is 3, and so on. I can also notice that that is the same for the number of smiles. Yep, number of smiles is equal to the number of meals squared. I also noticed that, so that means that the number of smiles is equal to the number of bows. Okay, so this is going to pick you up into, like I said, 4 marks in terms of this part of the question, okay? We also want to try and find a rule connecting these number of kisses. So connecting k in terms of m. So again, this is your quadratic sequence, okay? It's nothing different. I've got a piece of paper here, so I've got 0, 2, 6, 12, 20, 30, 42. So that's going up. First difference is 1, 4, 6, 8, 10, and so on. Second difference is 2. Sorry, first difference is 2, 4, 6, 8, 10. Second difference is 2. So it's going to be 1n squared. But in this case, so if I want to look, I'm looking at number of kisses is equal to, it's going to be number of males squared. And if I try that out, so if I have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. If I subtract off the original sequence, I get a linear sequence. And I encourage you to do this. So 1, 4, 9, 16. So let's see. 0 take away 1 is negative 1. 2 take away 4 is negative 2. 6 take away negative 3, negative 4, and so on. So it's going down. Common difference of negative 1. So it's minus 1m. Okay. Look, so guys, this is just what we did in class, okay? Working out these sequences is nothing crazy here, okay? Find a general rule for k in terms of m. Alright, done that. What else are we after? Find a general rule for b in terms of m. For b in terms of m. Oh, we've done that here. b in terms of m. So b is equal to m squared. B is equal to m. Come on, Cunningham. Doesn't want to work. Yeah, there we go. B is equal to m squared. Find a general rule for g in terms of m. Again, we're using the formula. It's going to be 7 over 2 m squared minus 3 over 2m. So again, if you want me to go through this with pen and paper, I can. That's the easiest way to do it, is just to write out your sequence, find your first term, first difference, second difference, find out the number in front of the squared term, and then look for your linear part, okay? But I'm happy to do that with you, but it's something that we've been doing last week, okay? So I'm going to put this in this form. So 7 over 2 m squared, and it's minus 3 over 2 m, and that is equal to the g. term. Test your general rule for G. Alright, so the test, all we need to do is stick in some numbers for this, okay? So we can put in, we could put in m is equal to 6, and if I get 107 out, then I am good. So G is equal to 7 over 2 multiplied by 6 squared and then it is subtract 3 over 2 multiplied by 6. So G equals, and you can put this all in the calculator. Maybe I should have just done that to start off with. 7 over 2 multiplied by 6 squared is 36. Subtract 1.5 times 6, 117. I'm hoping that's what I got. Maybe because I can't add. Yeah, because I verified it wrong. It should be 117. Okay, that makes sense. And then the next term, you silly man, 117 add 44, 4, 5, 6, 167. That's a good thing with this though, because you can actually check your answers as you go along, okay? I encourage you to all do this. Verify and justify your rule. What you want to do here is to work through that it's correct for other values. You want to make sure that your notation is correct, okay? You're using M's and G as it is written. If it's capital G, you've got a capital G. If it is a small m, you've got a small m. You're not using X's if it doesn't have X's, okay? Only use what they have. And then ensure you communicate all your working properly, okay? So as we work through, kind of setting it out nice and neatly, and you're including everything in there that you need, okay? Now I've kind of worked through that a bit quickly. Like I said, I'm happy to go over any of it with you. I understand that this is worth 24 marks, so there's a lot going on there, okay? But it is so easy to pick up marks as you work through it, okay? You're given all the information you need, okay? And it's just a quadratic sequence question. You're doing the same thing over and over again, okay? Give me a shout if you need any help on it, and I'm happy to go over it with you. Thursday lunchtimes I'm available, okay? So come up and see me anytime or drop me an email. All right, have a good evening. Bye.